Okay, so we'll go into the properties properly. I am having my text because sometimes I may need to write some of these things very technically. It's something that I over the years I've been able to develop a way to understand what to do. This understanding I'm giving is actually something I developed myself. I found it out myself. Sometimes a further maths, you may need to find some things out yourself. Also in maths. So what is closure property? I'm going to give a very simple way I used to understand closure property. If I relate two elements with an operation, usually we use asterisks, and this is what it means. If I have, okay, so we're trying to look at the behavior of the closure property. I have an element operated, two elements having an operator star, asterisk. Now, I obtain an element C. For instance, I obtain an element C. If this element I obtain C is a part of the set I had defined earlier, we say that there is what? Closure property. Now so technically, this is how we write it technically. We have an element A, B, belong, you're already conversant with this if you have done set, belong to S. We say that if AB belong to S, and when I do the operator, it also belongs to S, we say that the property here exhibited is a closure property. It sounds abstract, but I think this first line I wrote would have helped you out. If I operate this on this, if I operate these two elements, element A and element B are already elements of a set S. S is just a definition of the kind of numbers you will see there, or the numbers I have described to be in that set. If the operator, if I operate A on B, and I obtain a new element C, such that this C is also a member or an element of S, we say that that the operation is closed. Is closed. So it means that I can say that closure property is being obeyed there. We'll take that again. Is two elements belonging to a set are said to be closed under the operator asterisk if the new element we obtain is also a member of that set. I'll come again. Two elements A and B of a particular set S, that if they are said to be closed, if closed under the operator asterisk, if the element, the new element I'm getting is also. Now let's do that practically, because sometimes this is where it gets abstract. If I say A operator, or let's say 1 plus 2, I get 3. Is that not? 1 is a natural number, or is a whole number. 2 is a whole number. 1 plus 2 will give me 3. So what do I say? I say that this operator, that this answer I've gotten is also a type of these numbers I've worked on. So we say that the property, the exclusion property, that this operator, that the elements are closed under the operator plus. Let's see what happened to subtraction. If I say 1 minus 2, I'm going to have negative 1. But remember that I am dealing with set of what? Whole numbers. Because if I change the narrative to integers, the answer will change too. But I'm dealing with whole numbers. So under whole numbers, negative, positive whole numbers as it were, positive whole numbers. I'm getting negative here. So this one will not be closed under that operation. Now, if I say 1 times 2, what do I get? I'm going to get 2. 1 times 2 is 2. 2 is a positive whole number. Notice that now I'm dealing with n. N refers to what? Natural numbers. And what are natural numbers? Natural numbers are whole numbers that are positive. So I'm dealing with positive whole numbers. So under the description of this operator, only these two are passed the test. Let's see if I say 1 divided by 2. I'm going to get 1/2. This is not possible because I am dealing with natural numbers. So you see that this is the description of what closure property is talking about. If I now change it to, let's say, I'm now working with, let's say this is natural numbers now. I now change it to something like integers. Oh, did I say natural number? Yes, n. It should be n. I'll use n for natural numbers. Let's say I'm now, because sometimes the narrative will change. I'm now working with z. I'm working with z. I'm working with z. All right, so if I change the narrative to z, z represents integers, either positive or negative. But if now you have to be careful because sometimes they could write this. This means positive integers, and they could write this. This means negative integers. But I have defined integers. Now, what are integers? Integers are essentially whole numbers that are essentially positive or negative. So if you look at it, this is a whole number that is positive. This is a whole number that is negative. This is a whole number that is positive. This is a rational number. For integers, we would have, when we test, the answers we get, it will only be true to the extent that we have what? This is an integer, positive integer. This is a negative integer. This is a positive integer. This is a rational number. So in describing closure property, the set of numbers, let's say 1, 2, will not be, or rather 1 and 2, or the elements in that description will not be closed under the operation division. It will not be closed if I'm dealing with what? Integer. But if I'm dealing with natural numbers, I only have addition and multiplication as being closed. So that's what it means to talk about closure property. But if I increase it to real numbers will cover whole numbers, integers, rational numbers, and irrational numbers. If I'm dealing with a larger family, then because I'm dealing with real numbers now, whole numbers will be there, either positive or negative, and also my rational number will be there. So, because this is where students usually miss when it comes to this closure property, particularly binary operation, you must have a strong knowledge of the properties of a particular group of numbers to be able to deal with. Now, we're going to solve, maybe handle a few questions, maybe 1 or 2, and then we're going to see how that plays out. Right? So we will go to, like I've said, we can pick examples. We can pick examples here, and we would go straight away. Let's look at example 3 in this text. We are on page 22. On page 22, and if you look at the example there, it says an operator asterisk. So an operator asterisk is defined on the set of real numbers. Real numbers. What are real numbers? Numbers that are natural, numbers that are integers, numbers that are rational, and numbers that are what? Irrational. So you discover that the grouping here is large. That's something you must remember when you're handling this problem. It's defined on a set of numbers, of real numbers, arrow. Real numbers are defined as capital letter arrow, such that x and y belong to arrow. Now, this is what it means. X, comma, y belong to what? Arrow. So we are told this is the definition of how the operator works. Because asterisks can take any form. But when they say x asterisk y, it will give you this. This is how they want the operator to work. Now, we are told to do what? Determine what? 3 * 2. So what this means is that anywhere you see x, put 3. Anywhere you see y, put what? 2. That's what it means. So this will simply be equal to what? Look at how it comes out. 3 plus 2 over 2. It means add 3 to 2 and do what? Obtain, add 3 to 2 and then divide it by 2. That's what they want you to do. So this will be 5 over 2. All right? Now, we go to B. Look at B. It says what? -4, -5 rather, star 4. What does that mean? It means negative, add them and divide by 2. And what would this give you? This will essentially give you -1 over 2. That takes care of that. So it's very simple. It's really very, very simple. It's just the understanding you need to take note of. Now let's go to C. In question C, it said 7 star 3 divided by 2. What would this be? This would be what? Oh, sorry, 7 star 3 or asterisk 3. It means add them and divide by 2. Add them and divide by 2. So that will give you what? 10 over 2, which essentially will be what? 5. Now look at D. It says half, asterisk half, will be equal to what? Add them together and divide by 2. Half plus half will be 1 divided by 2. So that will be half. If you look at the answer, because this is where closure property is tested. If you look at the answer, what is being tested here? What is tested is, at the end of the day, am I getting answers? Look at it. Am I getting answers that are members of the set? We said earlier that the set defined here is a set of, what? Real numbers. Set of what? Real numbers. So if they are real numbers, it means that natural numbers, integers, rational numbers, and irrational numbers will be that group. See the answers we have here. We have a rational number, so it's in that group. We have another rational number, it's in that group. We have a whole number, positive whole number, a natural number, it's in that group. And we have another rational number, it's in that group. So what do you discover? All of these are answers. And so we will say, in writing, I will say that what? This is how you now write it. Say that what? Let me change my marker, sorry about that. So we can say that if X and Y belong to arrow, this is how it is written from the knowledge of set. If X and Y belong to arrow, then it would follow that what? The sets. Remember that the property is defined with respect to the set. The set arrow is closed under the operation asterisk. If set arrow is closed, or that the set arrow is closed under the operation asterisk. So it means that as long as I furnish this set with any number that is real, the set will be closed. So we will also have another class where we will just solve only problems, but this class is just focusing on trying to give you the understanding of what to do. So in closing this class, what's the learning point? The learning point here is this. When we talk about closure property, we said that there are about 5 or 6 properties we're going to be considering. When we talk about closure property, we mean that if I define elements in that set and I carry out an operation on them, the answer I get, if the answer I get is a member of that set, we say that the element is closed under, or the set rather is closed under that operation. So we've done, we're through with the videos for this class. I want to advise that you rewatch it. We'll be doing another video where we will only solve problems. We'll solve only problems of closure property, because this area appears to be one of the most important area. Students find this area a bit abstract, but I'm trusting that at the end of this course, you'll be able to understand this matter better. I'll close the class for today and I'll see you in my next class.